on this page we're focused on using formulas, and again I'll give you the formulas on the test so you don't have to commit anything to memory. So this first couple of problems is just to get you used to looking at the formulas in a critical way. So there's not a whole lot to this since you'll have formulas written down. For the first problem, these are the two. Oops, these are the two that are correct. All the other ones have some small thing wrong with them. But hopefully by looking at this you'll be able to sort of see the patterns, how these formulas work, so that you know you're using them correctly. For this one there are only two that are not true. This one's certainly not true, because we know that sine squared plus cosine squared is actually equal to 1, so it's not always equal to cosine of 2 theta. And the other one that's not true is this half angle formula, which is bad. Okay, and again, the only way to know that, unless you committed it to memory, is to look and see. I mean, obviously one of these two must be wrong. They're not saying the same thing. Technically, this guy should have plus or minus out in front of it, because in this formula, it depends on what the value of theta is as to whether you get a positive or negative answer for sine. So you have to always take into account that that could be a negative answer, and you actually have to think about what quadrant the angle is in before you know whether it's positive or negative. But we've seen that before. So when we talk about using the formulas, these are the kind of problems that we might have. The exact value of sine of 15 degrees, well, sine of 15 degrees can come from this formula, for one, because if I use that formula when theta is 30 degrees, then the formula that's there says the sine of 30 degrees over 2, which is the sine of 15, is, and technically it's plus or minus, because I have to think about what quadrant I'm in, so I'll leave that there for a minute. And then under the square root sign, I have 1 minus cosine of 30 degrees all over 2. I can get rid of this plus or minus because I know that 15 degrees is a first quadrant angle, so the sine of 15 degrees has to be positive. So there's never going to be a plus or minus in your answer. The reason it's in the formula is because it could be a positive answer or a negative answer, but obviously it's got to be one or the other, and you can tell by what quadrant your angle is in. So if I finish this, I know the cosine of 30 degrees, and so if I don't mind writing a messy looking fraction, I can just say it's 1 minus square root of 3 over 2 all under the square root sign. So that is the value of the sine of 15 degrees. And if you want to, on your calculator, you can do this nasty looking square root thing and see what number you get. And you can do the sine of 15 degrees, see what you get. Don't forget your calculator has to be in degree mode to make that comparison. But then you can tell those are the right thing. The other way we could do this is by using the fact that 15 is 45 minus 30. So I'll write that up here. So I could do the sine of 45 degrees minus 30 degrees. And the reason that's useful is that I know the trig function values for 45 and 30 degree angles. So from the formula that I had above, the formula for the sine of a difference, I guess the one up there was the sine of a sum, but there's a formula for the sine of a difference of two angles that says you have the sine of the first angle times the cosine of the second minus the cosine of the first angle times the sine of the second. And so we can do that because we know what all of these values are. Sine of 45 degrees is square root of 2 over 2, cosine of 30 degrees is square root of 3 over 2, cosine of 45 is square root of 2 over 2, and the sine of 30 is 1/2. So this will actually be equal to, if you do all the arithmetic, we'll have square root of 6 over 4 minus square root of 2 over 4. And again, you put that in your calculator and you'll see that it's the same thing again. Okay, let's move on without the cell phone ringing in the background. The other kind of problems that you would have seen on your worksheet has to do with using the formulas that we were using to verify some identity. So this is just a matter of plugging into the formula again. but it's sort of a case where we know what the answer is supposed to be. So here, for example, the problem says to do something with sine of theta plus pi over 2, and so what I should do is just apply the formula for the sine of the sum of two angles, which says that when I have the sine of the sum, it's the sine of the first times the cosine of the second times the cosine of the first times the sine of the second. And the fact is that because one of those angles is actually known, pi over 2, I know cosine of pi over 2 is 0, and I know sine of pi over 2 is 1. So this is sine of theta times 0 minus cosine of theta times 1. Oh, sorry, it should be plus. The sine of theta times 0 is 0, so that's not really there. Cosine of theta times 1 is just cosine of theta. And so what this is really saying is that if you apply the sum formula to the sine of theta plus pi over 2, the answer is going to be cosine of theta. And so that establishes an identity based on our formulas. To do something with tangent, you notice that I never write down the formula for the sum or difference of tangent, and the reason is that it's really just the fact that tangent sine over cosine and then some simplification. So it's not worth really committing it to memory unless you really had to work with tangent quite a bit. So for example, the cotangent of the sum of two angles, well, that's just going to be the cosine of the sum of the two angles divided by the sine of the sum of the two angles. So we're just saying, just using the fact that we know that cotangent is cosine over sine. We have a formula for each one of these: cosine theta cosine pi over 2 minus sine theta sine pi over 2. And the denominator, we have sine theta cosine pi over 2 plus cosine theta sine pi over 2. So we're just applying our formulas to each of those two things separately, and then once again just using the fact that we know what these values are. Cosine of theta times 0 and the denominator, I have sine of theta times 0 plus cosine theta times 1. So all in all, I have negative sine theta over cosine theta, which is negative tangent of theta, which is what we said we were going to establish. So again, all I'm doing is starting with one side, applying formulas to it, and showing that I do get the other side in the end.